So now we have Fernando with us. Hope you enjoy. Thank you.
Okay. Se bloqueó la máquina. Right. All right. Hello, everyone. My name is Fernando Guevara. I'm Application Architect Manager at Pepsico. And today we will be talking about manufacturing. Sorry, give me a second. All right, no worries. We'll do it from here. So, okay, are we back? Yes, we're back. So today we'll be talking, sorry about that. We'll be talking about manufacturing. We will talk briefly about the influence of industrial revolutions on manufacturing. What are the techs, tools, concepts involving the use of IT systems in manufacturing, and we'll land in Industry 4.0, try to explain it a little bit, their key aspects, and, oh my God, can't believe it. So I'll stay here so we don't suffer this. And then we'll try to align AI with manufacturing. So, 3 takeaways that I wanted you to have from this presentation. We'll try to define all against vintage, classic, if we have time, with modern too. That automation is not automatic, and sometimes a kilogram of chips doesn't weigh the same as a kilogram of chips. We'll know about it more, hopefully, by the end of the talk. So a while back, Tim Urban posted this on his X account. He did a very visual comparison on if we take the whole human history and put it as a 10,000 pages book, it would look like this, pretty much. Not a lot changed for a while, up until recent years, if you will. But I wanted to take it to our domain, and what would have different humans in history have searched on Google, right? So for almost 240,000 years, not much in terms of complexity in our lives. How to make fire, right? Makes sense. How to find a good cave, who wouldn't want to live like that? And how to know if plants are poison. Okay, I hope the guy's fine. Then we started having early agriculture, started having more complexity into our lives, but still not a lot changed. Just some concepts that turn more relevant or new stuff. We started having empires, a lot of civilization-like technologies, and again, certain things remain the same. Some were new, and some concepts we were redefined and either continue being relevant or maybe fell a little bit into just history, right? And we approach modern times. In modern times, in a very short period, everything changed. There was a lot more complexity in our everyday lives, in our mindset, in our thoughts. So what happens with manufacturing, right? With manufacturing, there's a similar story, right? We can define manufacturing either in Spanish with manufactura, which means handmade, or with the more English definition of producing with the aid of machines, right? Whatever you want to take it, history of manufacturing goes a long way back, but not a lot really ended up changing until the industrial revolutions. So around mid-18th century, and of course characterized by the steam engine, there was a huge jump on the productivity of of manufacturing, of industry in general. We can see how much it improved for raw material creations in the case of the textile industry, how much the end product growth was. And we started seeing new things turn into everyday things, like the side of an industry in a city, you know, the chimneys, the smoke, whatever. 100 years or so later, the second revolution came, and that was crazy, like super crazy, because now you not only have to see it as, okay, we produce more things, like all the chemistry and physics field exploded, gave a lot of new opportunities, new type of constructions, new type of products, new avenues to move. And of course, it also improved productivity. I put an example of the force model, and for not only improve this productivity, changed the way factories assemble their products forever with the serial line of production. And again, almost 100 years later, and I say almost, you can already see how times are shortening. The third industrial revolution appeared, and this one had the particularity of it aligns with the computer revolution, right? When we ended the Second World War, and we started seeing computers as something the companies could afford to start to apply to a lot of maybe analog problems. So really the term of digital transformation started back then. The goal of this revolution, or at least the base, was to digitalize some of these industries, some of these processes, right? Of course, a lot of new things enable this, like the use of robots and robotics in the manufacturing plant, the microchips, of course, to be so small as to be able to put it at the same place as big machinery, and yeah, even to our days. Internet, it's a sub-product of that revolution, right? So out of that third revolution came the organization of the industry. They said, okay, so our goal here is to digitalize so we can automate. And for that, we created the automation pyramid. We love pyramids, we love triangles. At the lower level, we have the field level, which pretty much is the translation to the physical world, right? We can think of it as with TCP and the rest, where we have sensors and actuators, meaning we can know what is happening on the physical world and as well act on it. As we go up the pyramid, we start adding more and more automation and more influence of IT systems. When we jump to the controls level, where we find PLCs, those are programmable, or if you will, a compute unit that you can put in the flow of your manufacturer, and at least start seeing in a more cohesive way what is going on in the physical world, right? You at least can say how fast my machine is moving, how hot, how different type of things, and allow a human or even the computer to adjust a little bit the levels. The supervisor level adds what is called a wall-to-wall vision, right? Wall-to-wall means I see not only one line, but all the lines that are going on my plant, and I can approach the production as a plan, right? As I need to have this many crates or this many number of items, which of the lines will produce what number or which type of product, right? Then we at the management level. In this case, we take this idea of a production plan and we digitalize it. We actually have the production plan there, and we start combining it with other sources of data, right? What can it be? If you have humans, you compare it with the schedule. So okay, I will not only produce on these lines this type of product, but I will also put these people on the line during these hours, and so on and so forth. And finally, the enterprise level, which is a more strategic level, where we as a company put the objectives, and then from there, we lower those objectives to the different factories. For that, in 2006, a protocol was introduced. We were just discussing outside the case of the financial industry. There's another protocol called FIX. This is an effort to standardization, right? So OPC protocol was introduced in 2006, also as a layer-based protocol like TCP, if you will, with the particularity of supporting both the client-server architectures and the pub/sub architectures. The main goal to it was to promote the communication of data between all these layers, right? We'll see that the objective was changing. Most of this happened on the light blue that you see here. The rest are really the evolution the OPC is seeing nowadays. Key things is their native support to AMQP protocol and MQTT. There are options like COIP and other protocols. The advantage of OPC, it's the security layer they add on top of it. But those are all technical parts. How does it look in terms of components in an end-to-end, right? Doesn't mean that everything looks like this. I just wanted to establish a flow where we could see different components and how they affect the flow of data, of course, used for automation. We start, of course, with the physical layer, with the machines running on the shop floor, and the sensors either incorporated to the machines or outside of them, sending OPC messages. What you can see on the OPC message, you can think of it as a key value, right? You have your tag, your name of your key, and the value, the current value for that particular one. The sensors are just adding more information, right? More keys, more values to it. But then you reach layer 2, the control layer. And then it's where you first start making decisions on that data that you have, and also producing new data, maybe a summary of it, maybe a new component. And you move to the layer 3. Layer 3, characterized by the SCADA systems. These are the supervisory control system, this wall-to-wall view that we were discussing, with major players like General Electric and Rockwell there, that they take all these messages and they also produce their own, but in terms of production. Are we good with production? Are we having some downtime? Are we having issues in the production? The Kepware is a very popular concentrator. So imagine that a lot of machines, PLCs, and maybe one or two SCADA systems are in your shop floor. You want to concentrate all those messages into one place where you can connect from the next layer, which is where the MES, the manufacturing execution system, goes. Now it's when we start seeing a lot of different data. Not only this, I will just communicate what I'm doing to the next layer, but rather you have to take decisions, you keep context, you have to do a lot of things to fulfill your plan, your production plan, right? And finally, on a layer I call 4.5, but really it's maybe a subproduct of the layer 4 not completely fulfilling our objective or not completely being nice to integrate with this new development, like having cloud compute and cloud architecture. It's where IIoT, where appliances and new servers came in, and where we start seeing data as we are used to. We, as in software industry, right? Either transactional or analytic type of data. And we move it, some of it, all the way to the layer 5, which is the enterprise level layer for decision-making, analysis, a lot of different objectives, right? So, and in here is where maybe the objective of the third revolution and also how we use the term every day starts, making it a little bit of a bad sound to me, which is the difference between automatic and automated. Automatic, I think we achieve it, right? We managed to do a lot of processes without the human being in the middle. I still remember the classic movie of modern times where Charles Chaplin is on the assembly line and just tightening some bolts and whatever, and when he moves to his home, he's still doing the same movement, We make that automatic. The people can worry about fulfilling the plan and not about moving cogs there. But did we really have a success in automation? Are we fully automated? Thinking of automation as, can the machine adapt to the change of context, right? Of decision making in the spot by themselves? I don't think so, right? But that's why in 2011, the German government, so it's a more academic source, created the concept of Industry 4.0. It's like a revamp of Industry 3, the Industrial Revolution we had before, to try to aim for automation, real automation, right? So that's why I don't like the robotization part, but rather the search for an intelligent system, right, that can adapt. The usual suspects that we see here, and we are tending to be getting used to it, are smart devices, IIoT to that matter, for the case of manufacturing, the cloud, of course, super important, and AI, which is probably you heard a little bit of in these talks. But also new sightings, like we had the factory back in the first revolution. Now we see tech giants, right? We see few companies that has their own take on what automation means, and sometimes we have to fall on those labs, if you will. They are shaping a little bit the Industry 4.0 ecosystem instead of what was thought of in 2011. So they thought of 5 pillars that you can see on top, right? I will not go over each one, but at least we can appreciate 2 things. First, these words, these concepts are super familiar to us. You could be speaking about manufacturing as you could be speaking about software industry, right? The second is, nowhere here talks about intelligent, smarts, being fully automated. And I will not answer about that, but it's something that keeps an open question on if that's the end goal, if we are going to make it, and so on. But in any case, we have the enablers under that to at least fulfill these 5 pillars, and artificial intelligence, of course, in the center. So, what are the applications that Industry 4.0 have thought of? There are many, right? But nowadays, and with all we have been hearing on Gen AI and so on, human-machine interaction will certainly be rethought of, right? Something that we are allowed to move away from just a screen, where you tap your selections and you rather have a conversation with the machine. The predictive part of it, it's definitely seeing a lot of improvements thanks to AI in general, not Gen AI. Like for years now, they've been using advanced statistical models to understand when to change a machine, when to change parameters to improve the quality, so on and so forth. So there are a lot of examples, right? So those you can search on your place to your likings. I picked these three just to show you what were industry been working on for the last few years, even before Shen AI. They were already using computer vision for guided product, faulty product detection. This, we were also discussing before, the computer vision part works great. There's been a lot of improvements, but you have always the same issue. We are in the physical world, right? So if you move your machine or your conveyor belt by 10 centimeters, things get a little bit screwed, right? And we still try to go over some of those problems. The AI-generated recipes, you use deep learning models. They work great, but then hallucinations are not super nice, right? You don't want to go out with something that even has a 2% error rate, right? Because somebody will try to make a cheesecake with meat or something like that, you know? And then HEV, which is talking about oxymorons. HEV stands for Automated Guided Vehicles. I don't know who put the name there, but you can pretty much see automation. They are automatic, but not fully automated. But still, this Amazon use case was one of the first of the dark-like type. Dark means, at least applied here, is a subsection. This is a dark workshop, so a subsection of the manufacturing plant where there is no human whatsoever. The robots will do all the work by themselves unless they broke up or unless there is a major event, but everything will be done now, yes, automated. Right? So we had the super beautiful layered pyramid at the beginning of the Industrial Revolution, but then things get started to complicate a little bit, and just for us, this eternal monolithic versus microservices architecture discussion, the OPC organization said, okay, now we need to rethink of it. Instead of so structured, layered approach, we need to think of it as a network, right? As a network of third-party providers, as a network of our own services, smart devices, where they relate and provide decision-making to different layers, despite on where they are sitting. If they are in the cloud, in the shop floor, in your smart device, whatever it is. So it's been a quite a ride so far. We started with the 18th century, and now we are in complex graphs. So I want to take like a side quest with you, discuss a little bit about methodologies. For a while now, we stopped discussing these project-like methodologies, like waterfall or agile, and we, thankfully, to be honest, we moved to product methodologies, right? The double diamond, it's a super nice approach. That's why we started hearing about the discovery world and phase. The approach of having diversions just to converge later, so it means we take in as much as we can, and then we process it to produce a singular result. And it's quite related to some other concepts that arise in these later years, especially the one-way and two-way door, which is a concept, I think, from Amazon leadership, which is super interesting because it says pretty much, for those that don't know it, there are decisions that you can take, but never or costly get back to, roll back or change, and decisions that they're less costly to you. Decisions that you can either roll back cheaply, or you can take another one quite close in time to revert, right? And that applies to manufacturing where you're in the real world, where your company revenue depends on you producing 24/7. It's quite a big deal, right? So how can you support your decision-making process in order to differentiate these one-way or two-way doors, right? So that's where observability comes in. Again, trying to redefine a little bit observability as not only monitoring what's going on, but also how does the current state of things relate to your objectives, right? And governance. And for governance, doesn't mean permission, rollback, RBAC or whatever. It means who's going to take the decisions on your product as to be able to fulfill your objectives, right? For that, when it comes to manufacturing, there is a key KPI, sorry for the redundancy there, but that's called overall equipment effectiveness, OEE. And it's a little bit of an industry standard, if you will, even though the components inside that percentage can vary a lot. But it usually is seen like this in the shop floor. It's a quick, easy way for people working there to say, hey, are we on track or not, right? And that not only gives humans the sense of are we on the right track or not, but also we can implement more methodological approaches like the Six Sigma things or Three Sigma or whatever, which translated to our concept is pretty much the how many nines I want after my comma or my point. And that way, this observability, this governance turns into a more coherent approach. So based on that, there's another concept called digital thread. You probably already heard about digital twin. Digital thread is really this concept apply, right? So I want to be able to match pieces of code with machinery I bought, with objectives my company has, with the current state of production, everything together, bound together by this digital thread. Super ambitious, I know, but it's the way to represent that. It's so important the decisions we make because it has an impact on the physical world that we need a lot of tools for it. Now, going back to our journey here, right? We started defining manufacturing, how it is today based on its history, the techs that involved the manufacturing. But it's something that also applies to Gen AI and everything AI related. Not all is wonderful, right? We have a lot of problems for implementing our idea. And I wanted to bring attention to a couple of problems related to data that we faced every day. The first one is the data move problem, right? So in terms of data move, the cost of storage has lowered severely over the years, so not a problem. The cost of transmission also lowered. So if you take those things separately, not a lot of problem there. Not much cost, which is what affects the companies most. But what happens when we add why I'm using this data and what for, right? I added two examples, super simplified. So I want to know the units produced and the downtime count with the reasons. But see how much it differs depending on how I'm using that data, right? If I want to measure my OEE, first of all, I want it real time, because that's what it's going to tell by the second to my shop floor if they are on the right track. And I'm bound to how much information I can get to calculate that, right? So again, oversimplifying, but I'm saying I'm sending one message a second over 24 hours to achieve that. But then I also want the units produced count, but just so to create a report to management, right? And management only sits to see that report when the shift ends, right? So in that case, I only need to send one message with a completed count every 8 hours. So the orders of magnitude of the amount of data I'm sending and to where changes quite drastically. And it's slightly the same case with downtime counts, but this I added with reasons. Reasons means for downtime why the production line was stopped, right? And why here changes a little bit of everything, right? Why? Because reasons can either be standardized or not, meaning I have, for just adjusting the speed of the conveyor belt, I may call it like that in US. Somebody will call it something different in Spanish that can translate or not, or someone can call it something else in Holland, right? Or we can normalize it. We can say this is a categorization we are doing, and that's it. Okay, but what do I do with the downtimes that have nothing to do with this? You know, a bird came in from the window and right into the conveyor belt, and now I'm stopped. Right? How I justify that with a drop-down list, you know? So in here, we don't only have the problem of I move this counter up the chain so somebody can understand it, but I also need to move the reason and be sure about the reason. And maybe I will have to come back for the reason and say, no, this really wasn't it. I need to change it. So the data move problem really, and I think Javi Santana stated it better than myself. By the way, if you don't know him, he's in many conferences, he's the founder of TinyBird and super knowledgeable when it comes to data. He said, the fastest data is the one that you don't read, right? So the fastest way you have of processing your data is if you don't read it, right? But you don't fulfill your objectives. But that means also that the more to the left you shift your processing, the faster you get your answer. In our case of the unit counts, right? If we have the unit count on one of the PLCs or one of the earliest stages compute, then whenever that value is needed, I can just send it. And I keep computing it without expending anything on the cloud, not huge Databricks clusters running for it, and so on. And then the second fastest is the data that you don't write, right? Again, shifting left also means that the data that needs to go to the upstream, it's a lot less. So as you can see, sorry about that. As you can see, there are a lot of considerations to have when moving data, that there are multiple consumers, contextualization, so on and so forth. Not only that, the objectives for that data can vary a lot, so the same piece of data we can end up in multiple places, and you have like a million tools to use, and none of them will do everything, and none of them will be applied to all the use cases. So it's expected from us to be knowledgeable a little bit about all those tools and what are the strong aspects and the weaknesses. But in reality, we are skipping a super important part of our work, which is the data strategy. And I'm not talking only about retention, about recovery. I'm talking about what's the shape of the data, why we're using it for, what volume we have for receiving it, and who are the receptors. We have to really sit down and say, okay, who will be our consumers? Who will be their needs? You know, what are going to be their needs? And that gives us cue to the second problem, the data quality problem. So we're talking about companies that are over 100 years, right, for manufacturing, most of the big ones at least. Or even if it's new, nobody starts with a level of maturity that is quite hard. So it means you don't have a super good auditorial system and full of data where you consider from the beginning each of the pieces that you wanted to keep. So most of them face one or multiple, I would say, of these issues. The siloed information, I don't really have to explain it. The Rome effect, yes, I do have to explain it because it's something I expressed. The Rome effect, to me, is this. You know how Rome is a city that is really built on top of many cities, right, along the course of time. But not only that, it affects things like subway, right? Why you go to Rome and there are only 2 lines of subway that usually run to opposing points of the city? It's because at one point, building a subway system in Rome was impossible. You dig a hole and you found another piece of the city that it's maybe 2,000 years old. For all companies, it happens a little bit of the same thing. You go to the data schema and you find a table that was created 50 years ago, then added a couple of fields during the 80s, and then they tried to make it relational because that was the hype in the early 2000s, and now somebody had a bright idea of adding a NoSQL, I don't know why, into the mix, you know? So all this up to keeping the status quo, which is also a social, but an influence on your data strategy. People that just don't want change because they've been working like that for a while. And also, and this I will use the meme, some things are like that, and at this point we're too afraid to ask why, you know? But all of this, I think, really represents one thing, which is data doesn't reflect the reality. And for manufacturing in particular, is super important because we are building actual real products, right? How much important? This is ridiculous. Most companies calculate, this can vary a lot, but calculate that 15% of revenue loss because of data quality issues. That's a lot of money, a lot of money to be losing just because we didn't prepare before or because we are carrying over errors, right? So a couple of things that can help us fight this. Have a baseline, meaning know how your production was before you started making changes, know how your KPIs were being fulfilled before you started making changes. Clear data governance. Who is going to really tell you what a piece of data means? The innovation mindset, and this is super important and also missing in the industry because there is this industrial espionage mindset. If you want to innovate, meaning a data scientist that wants to explore data or a programmer that wants to understand if they can automate something, has a lot of walls. You cannot reach information, even if it's not personal information or not critical information or not secret information. It's super hard to reach it. So for companies to keep in an innovative mindset, it's super important also to be able to understand quickly and easily the data they have. Discovery, simulation. Simulation in particular leads to the digital twin concept, right? So we know what we do has an impact on the physical realm. We know that we have to avoid making a lot of changes because it's going to affect your production, your revenue. How can you still innovate and still do things, right? So digital twin is part of that solution in the whole ecosystem of simulation. Digital twin is a digital representation of something, yeah? In general, for manufacturing means a digital representation of your shop floor, including pathways, machinery, even people, if you will. And again, it's a super difficult concept that to achieve. But now you can see how important it is, because it will save us money in the long run to try to see if our changes are going to affect or not positively the production, right? If this is going to be more attainable by what Pablo was discussing before about multi-agents and what we've been hearing all these days, I do not know, but certainly it's quite a related concept, right? So I'm almost at the end. So for those who are hungry, yeah. One of my final approaches was to have a use case sample or an example here. I have my companies which produces the maize chips, We have a packaging line, meaning the machine that puts the chips on the bag and closes it up. And my objective, my idea with this project is I can use a deep reinforced learning model to improve productivity of this packaging line by reading the sensor data and producing adjustments to the parameter. Parameter meaning how big or small the conveyor of the chips will be, how fast the bags will spin, and so on and so forth. So for that, I'll send a batch, in a batch form, this sensor data using my IIoT network, right? Which definitely will have a pipeline in the middle because I don't want to send all of the events. I just want to send those that I want to send. And maybe the value doesn't make full sense for my model. So I will make some transformations, so on and so forth. That's why also I put Kafka here. That's become a little bit of a standard. So by that means, I uploaded a bunch of files, right, to Develop. And those are going to be the input to my data scientist, which build experiments to understand if they can really achieve this, right? They can really build the model and train it and push it to production. For that, I will need a workflow and modeling tool, like it could be Azure Studio in this case, but you have a lot of different tools. And those data scientists, maybe them or with the help of the dev, will elaborate a proposal for a model, right? And I will build that model using other parts of that batch information with a training flow. Again, in this case, that's a piece of computing that we are doing. That's why it's in AKS, in a Kubernetes cluster. And that training, what it really does is I also created a simulator based on that data. Simulator is a representation, this digital representation of my packaging line, and spin up a simulator, right? In this case, I put it on the cloud because it's a third party that is really providing me the simulator. I just provide the data or the flow, and they provide the simulation. And that training flow will use the simulation, will create the model, blah, blah, blah. I will push the model to an ML ops or an ML lifecycle management tool like ML Flow. And with a CI/CD pipeline, I will deploy it to as an agent on the edge. On my edge, there is a bit of an ecosystem for microservices because I don't only deploy a DRL agent, I deploy a monitoring tool, I deploy an input web application, whatever it is. So that's why the presence of micro Kubernetes, which is just a framework for running Kubernetes on smaller devices. That DRL agent, once it is running, it will pick up the signals from the current signals of the packaging line, will produce recommendations to a HMI, which is a human-machine interface. And that human in the loop will say, yes, I will apply these parameters, or no, I will not apply them, right? So that's the complete flow. So in my company, we're super happy because we went to this factory and the experiment was a success. So it was giving parameters. We improved productivity by 2%. 2% is a lot. So we were super happy. Now, I had a factory across the world, and I wanted to send this same model and do their work because they have the same machines there, right? So now, raise your hand who thinks that went really well and now the model is running on the new factory and all is good. I like your positivity. Thank you, Sonia. No, it didn't work, but really, why? Because I have all the technical pieces. I mean, it's not the best architecture for sure. It's not super cellular or microservices-like or whatever, but it works, right? This works for one factory. So in this case, the reason it didn't work was because in this particular factory, they weighted the chips before I added the flavor. right? Why? The chips don't weigh the same after the flavor. Of course, this powder only adds a little bit of a weight to it. So by the time they reach my packaging line, my calculations, my model, just produce very, very wrong answers, you know? So see how this tiny detail, which for us, when we go to a new site, when we are used to working with software solutions, just turnkey type of thing, you say, you know what, you just give me your data, it needs to be this shape, and I do the rest. We want to do the same here. Just give us they gave us our data, but they forgot to tell us they put the sensors in a different position, you know? So that's how much dealing with the real world affects all this, right? So I had to add it. I couldn't be the other way. But now that we had an overview of what the manufacturing world looks like, we can look into the future, right? And into the future, sorry, the companies thought the end goal of Industry 4.0 needs to be dark factories, right? We discussed this dark concept. Just as today we have dark workshops, so pieces of the factory that no human goes there. They want to have it the whole thing. It's just receives raw material, out the product goes, right? So on the right corner, you can see what they are aiming for, right? And you notice one thing during the whole talk, I didn't even consider things like sustainability, right? If putting the sensors in the wrong place, can you imagine my decisions will be affected if I also want to go with something as important as sustainability, which, by the way, you will hear more about afterwards. But to me, I really want to see if this is going to happen or not. And most of all, I want to see if Gen AI and the LLMs and whatnot, it's going to be the answer to it, and that can fulfill all those 8 pillars that they set. So, going back to the takeaways, right? I hope we are on the same page here. When I said all, I mean manufacturing is old, right? It's something that's been going on for ever almost, for like 5,000 years, right? But still a little bit new to us because things change. The technologies and the approaches we took, they turn either into classic or vintage. We still use it because they are relevant in the case of classic, or we still use it because we are afraid of change, like in the case of vintage, or because it's a fashion. So all these new concepts that are the modern part, the Gen AI, cloud computing, additive manufacturing, they still need to prove themselves on where they will fall. That automation is not automatic. I hope I made that point quite clear. We are not there yet. We have a lot of things automatic. We are not yet in automation, full automation. And why not always the kilogram of chips weighs as much as a kilogram of chips? It's because in reality things happens, right? Thank you so much.
Thank you, Fernando. We do indeed have time and some questions for you to answer. Some ironic ones. I would say, can you shortly refer to why you got rid of endless and often useless policies of agile and waterful?
I think we got rid of them. They are still relevant, but and Neil said something similar on the initial keynote. We need to stop being dogmatic about it. I think we already did in some cases, which means take from each of the methodologies what works for you, which is not an easy decision or an easy thing to do. In the case of waterfall, I think it became vintage, really. The one that is still using it is because they feel comfortable with it. It's not super relevant right now. Agile has so many forms that you cannot really define it. So what people tend to do, and it's logical, it's I will take Scrum, or I will take, I don't know, Kanban boards or whatever. So pieces of the methodology that helps you. But in the end, the biggest shift and the most valuable, I think it was the shift to a product-based, because now I'm thinking in terms not of the technology and not of the tech stuff, but rather what the business needs and what's my current context.
Great. You mentioned the digital twin. So the question is, how digital twins can help in manufacturing, and how can AI be used to increase their value offering?
So digital twin, it's a broad definition. Right now, the companies have either two approaches. One is I do like a old-fashioned simulation where I have even my 3D models of the machines and build pretty much a game, right? Where my ideas turn into players of that game, which is a correct approach, but you need to really know well all the physics of your machines, a lot of key aspects that, to be honest, it's super hard to accomplish. And then the newest approach is I take the key concepts and turn it into an agent, right? So something that has context, that have knowledge base, and that can interact with us. And through that, with us and other agents, and with that interaction, let's see what happens. You know, it's this, whoever read Hitchhiker Guide to the Galaxy, you know, it's let's build a world, see what happens, and come back with an answer. Hopefully something other than 42, but yeah.
Thank you. And the last question would be, you mentioned API-driven development. How do you promote and drive that?
It's a good question, and it's a broad subject. So first, we can start on the what, API-driven, I think we all know. The why it's needed is because all these silo pieces of the organization, especially on large organizations, need clear understanding on how to integrate. But not only that, I don't have the time to go pitch my offering to other teams or other organizations within the company. So exposing an API, it's at least an easy way to show my offering, right? And without having to go and sell it a little bit. How to implement it? In those terms, there has been a lot of advances. Most of the companies goes for third parties like Apiumhub. Yeah, I mean, those Apiumhub there also. So they either give the third party the management part and the governance, or they keep part of the governance but move the management, the resources part to a third party, because what you really want to attain is, do I have my offering well placed in that API search engine and service offering or not? Building servers and API gateways turn into a commodity. That's the reality of it. It's 3 clicks.
That's so true. Okay, so thank you, Fer. Big applause for him.